Good morning, student. Today in this series we are solving Cbse question papers of science student, the year 2019. Today also, student, I will explain you some of the tips and the answers of the question which has been asked in Cbse 2019. It is the paper we are solving at present is outside Delhi, student, and today the class for the date is this, student. The student, one of the questions which was asked was the refractive index was given. Refractive index of ruby, RUBY, okay student, and this was given to be 1.7, and the question was we have to find speed of light in ruby. Find speed of light in ruby, student. This was the question which was asked, student, and it was also given the speed of light in vacuum. As you know, student, already it was given 3 into 10 raised to 8 meter per second, student. Okay. As you know, student, the formula of refractive index is given to be speed of light in vacuum, speed of light in vacuum upon speed of light in ruby. Okay, student, this quantity is given to you 1.7. This, student, which refractive index we have already learned. This is absolute refractive index, student, and the formula already we have done, student. The formula for this is C upon V. C is the velocity of light in vacuum, V is the velocity of light in medium. This mu has different symbol in some book, even it is n is written also. It is also same thing, student. Now here, since the refractive index is given ruby, this means the light is with respect to air or vacuum. So now, student, this problem is this 3 into 10 raised to 8 upon speed of light in ruby. This I am writing as VR. This will come out to be 3 into 10 raised to 8 upon 1.7, student. This, student, you have to solve it, and I am writing the final answer of this. You will get, student, around 1.76 into 10 raised to 8 meter per second, student. This is how this kind of question has to be solved, student. Already we have solved this type of question before also. Now let's go to the second part of the question, student. The second question was asked about the mirror, about a mirror kept in front of the sun facing the reflecting surface, student. Okay, and the question was how the mirror should be kept so that the paper kept in front of the mirror starts burning. Means we are focusing the sun rays, student. We are focusing the sun rays. See, student, the question is, I will be sending this question also, student, by in writing form also. The question was a student holding a mirror in his hand directed the reflecting surface of the mirror toward the sun. Means he faced the mirror towards the sun, reflecting surface towards the sun. And he then directed reflected light onto a sheet of paper. He directed that light to the sheet of paper, student. And the question was, what should he do to burn the paper? Which type of mirror he should have? And what he should do to burn the paper? Say, student, suppose this is the sun rays. This is the sun, student. And the rays are parallel rays are coming like this. So he should place he has kept the mirror like this, say. So, student, you must have understood which kind of mirror it should be. It should be, student, concave mirror. The mirror must be concave. Now these rays will be reflected back, student, here. As you know, the law, angle of incidence is equal to angle of reflection. And they will collect somewhere here at this point is known as, student, focus. Here if I keep the paper, this paper will start burning, student. The paper will start, student, burning. And how this will burn? Paper has to be kept at focus, student. Paper has to be kept at the focus of the mirror. Or you can say that where the mirror starts, where the paper starts burning, that point is the focus point, okay? Actually, it will be the focal plane. The image will form in the focal plane, student. And what is focal plane? It is a plane perpendicular to principal axis passing through the focus. Because here the rays are parallel, but they are not parallel to principal axis. So the rays will collect in the focal plane, student. And this distance, if you measure by the scale, this will give you the focal length, student. The focal length between the paper and the mirror will give you the distance between the focal length and the mirror will give you the focal length, student. This is the theory. This was the question which was asked, student. And then, so this was about the concave mirror, student. Now, the next part of the question was a numerical was asked. And the numerical was, student, a 10 centimeter tall object means height of the object. Height of the object is 10 centimeters, student. And it placed perpendicular to principal axis of a convex lens of focal length 12 centimeter. Lens is convex lens, student. Convex lens of focal length 12 centimeters, student. As you know, student, this sign will be plus. Height of the object also is plus. Two data are given, student. The next part is the distance of the object from the lens is 18 centimeter. The distance of the object. Distance of the object from the lens is 18 centimeter, student. Find the nature, position and size of the image. This is U, student. It should be minus. And the question is nature, position and size of the image, student. We will start with the lens formula as usual, student. 1 upon V minus 1 upon U is equal to 1 by F. V position you have to find out, no sign, minus. U is minus 18, student. F is focal length, which is plus 12. Now if I solve it, student, 1 by V will be, this is plus. Transposing the side will make it minus. Yes, student, now you have to take the LCM. 12, 18, 36, 12, 3 are 36, 18, 2 are 36, student, 1 upon 36. So V comes out to be plus 36 centimeters, student. Position, we got the answer, student. Now, student, size of the image. For size of the image, student, this is the formula. Height of the image, height of the object is equal to V upon U. Height of the image you have to find out. Height of the object is given. V just now we have calculated and U is minus 18, student. 18 to ja. Height of the image comes out to be minus 20 centimeters, student. Size you got. Now nature, student. Nature, student, how to find it, student? Since the height of the image is negative, this means, student, the nature is real and inverted, student. Real and inverted, student. So this was the question which was asked, student. You must have understood it. Now one more way to check the nature of the image, student, by this formula, student. Magnification is given by V upon U. V is minus 36, plus 36, U is minus 18. M comes out to be minus 2, student. the sign negative m means real and inverted. The image is real and inverted, student. So this is how, student, you have to solve the question. You have to remember the sign convention always. And the sign convention is, student, how you draw the lens. You draw the lens, student. One side you keep the object. Light is traveling this side, so this side is positive, student, and this side is negative. Now object distance I have to come from here to here, so u will be negative. Similarly, student, upward side, this is positive and below side is negative. This is the origin, okay, student? The light travels, that direction is positive. This sign convention you have to remember, student, and you can solve the problem very easily. Let's look the other question, student. Now, student, one more question of the set 2 of the 2019 set was, in this question, student, the power of the lens was given. The question is, the power of the lens was plus 5 diopters, student. Given power of the lens plus 5 diopters. The first question was nature and focal length. Nature means, student, the power is positive, hence the nature, it is a convex lens because power is positive. And focal length can be found out by this formula, student, 1 upon p. This is the formula, and this comes out to be 0.2 meter, which becomes into 120 centimeter. This was the first part of the question, student. Now the next part of the question was, at what distance from this lens should an object be placed so as to get its inverted image of the same size? Student, the question is, object distance you have to find out such that the image is formed. The image is formed of same size, and also it is given inverted. At what distance from this lens should an object be placed so as to get its inverted image of the same size? Inverted image of the same size. Where I should place the object, student? Now, student, when it is given the inverted image of the same size, this you have to note, student. The inverted image of same size means the value of m is 1, and since it is inverted means real, so m is minus 1. This data you have to note it, student. So m is minus 1. Now the formula for magnification is v upon u, student. This is minus 1 is equal to v upon u. So v is equal to minus u, student. Now if I keep the lens formula 1 by f, in place of v I will write this value minus u 1 by f. This will become, student, minus 2 by u is equal to 1 by f. So u comes out to be minus 2f, student, and f already we have calculated, minus 2 into 20. So answer comes out to be minus 40 centimeter, student. Means the object should be kept at a distance of 40 centimeter, then the image will be real and inverted. This, the ray diagram, we have already done it, student. How to draw the ray diagram of this, student? See, this is the lens. This is the lens, student. This is F, this is 2F, this is the object. One ray parallel to principal axis will go from here F. Another ray through the optical center will goes here. So this image will be same size. It is formed at 2F, student. The size will be same, student. This kind of ray diagram can be seen. This ray diagram can be drawn in the graphs also, student. In graph paper, you can choose the scale. For example, here I am getting U is equal to 40 centimeter. So you can make a scale that x-axis 1 centimeter of the graph will represent 20 centimeter. Y-axis 1 centimeter of the graph will represent, say any value you can take around the numerical. Say you can take 1 centimeter to be say 5 centimeter. Means 20 can be drawn by 1 centimeter line. And like that graphically also this diagram can be drawn, student, more accurately, okay? And whenever the power of the lens is given, student, you have to remember, you have to see the unit. Diopter means the focal length will come out to be, student, in meter. That you have to remember about the diopter case, student. Now, student, one more question which was asked in this: should the resistance of a voltmeter be low or high? Give reasons. Means the question was should the voltmeter should have high resistance or low resistance? So student, by drawing the circuit diagram, see, you can find out. See, this is the resistor, this is the cell or the battery which is connected here, student. Say this is 10 volt. Say this is 5 ohm resistance. So how much is the current, student? Current is this much. 10 upon 5, it is 2 ampere. So if I connect an ammeter here, it will read 2 ampere current, student, okay? Now suppose, student, I connected a voltmeter here. Now, student, what will happen? This is sending 2 ampere current, but some part of the current will go to the voltmeter also, student. Because to run this machine, this voltmeter needle, some energy is required. So it will take some amount of current for its operation. Now that instead of 2 ampere here, the current through this resistor will be, student, I am writing it here, 2 minus I dash. Now, student, value of this I dash, if this current is high, the current will become less. If this current becomes high, this current, the net current which is passing through the ammeter, this is the net current, ammeter, which ammeter will read this current. Though the ammeter will still read the total current, student, what I am saying, the current passing through this resistor, student, this resistor, this will become less. Current will become less due to the voltmeter. Now we want the current should not become much less. It should be approximately same. For this to become, this I dash should be very small, student. This I dash must be very small. And to make this I dash small, voltmeter must have high resistance, student. This basic you have to remember. The voltmeter must have a very high resistance. Voltmeter must have high resistance. And for ideal voltmeter, this resistance must be, it is written as infinity. Ideal voltmeter should have a infinity. So I have you must have explained understood the basic of the question, student, why the voltmeter should have high resistance. This was one of the questions which was asked in Cbse 2019, student. Then science we have, this is set second question. Set third also some questions are there, student. And one question was here about the convex mirror, student. I am solving all the sets of the questions, student, which are asked in Cbse 2019. Now set 3, there was one question. A 6 centimeter tall object is placed perpendicular to principal axis of a concave mirror, focal length 30. The mirror is concave, student. Concave mirror. And the focal length was 30. The concave mirror is a negative, student, you have to remember. Concave mirror, negative focal length. 30 was given, student. Height of the object 6 centimeter. Height of the, I am writing HO 6 centimeter, it will be written in plus. It is above the principal axis, student. The distance of the object from the mirror is 45 centimeter. The distance is given, student, 45. I have written minus. Now mirror formula determine position, nature and size of the image. So this is the mirror, student. This is the principal axis. This is somewhere the object is placed. Now student, we will apply the mirror formula. 1 upon V, 1 upon U is equal to 1 by F, student. V we have to find out, U is given, focal length is also given, student. Now if you solve it, student, plus 1 by 45, 1 upon V, LCM, student, you take 90, 33 is 90, 45 2 is, so 1 upon V is minus 1 by 90, so V comes out to be minus 90, student. The V comes out to be minus 90, student. The rest of the part already you know it, student. The size of the size can be found out by this formula. This is the mirror case, so it is minus V upon U, student. Height of the image I have to find out. Height of the object is given 6. Minus V just now I have calculated minus 90, and U is already given minus 45. 45 to the 90, this minus minus plus 1 minus remains, and HI is minus 12 centimeters. So the image is real and inverted, student. Real and inverted. Rest, and now we have to draw the ray diagram, student. So ray diagram can be drawn, student, by the rules which I have already studied. One ray parallel to principal axis will pass through the focus, another ray through the center of curvature, will return back, and like this you can draw the ray diagram, student. So student, today you have to practice these questions which have come in Cbse 2019 in your notebook, student. So today, student, this much only. Thank you for joining this class.